Hello everyone, welcome back to another episode of Math Unlocked. I'm your host, Mrs. Rhodes-Grierson. What are we doing today? Today we're looking at the inverse of a 2x2 matrix. I hope you have already watched the video on the determinant and the adjoint. If you have not yet watched that video, it means that you need to pause this one and go back, find the video on the determinant, find the video on the adjoint. Watch those two videos and then come right back, because those two videos are connected to this one, and it means that everything in math is connected and we need to see those connections. So let's go. Now the inverse of a 2x2 matrix requires that we follow the formula that says the inverse, and notice that there's a symbol representing the inverse. So P raised to the negative 1 here is representing the inverse of P. So this is the inverse of P. There's a formula that we use for the inverse of P that says P inverse is equal to 1 over the determinant of P. And this is why we needed to have gone back to watch how do we find the determinant and how do we find the adjoint. So we're looking at 1 over the determinant of P times the adjoint of P. Notice it says 1 over. So we're going to go into this idea of fractions. If you're not so great there, you may want to do a little brush up. Check out a video, one of the videos on fractions, so that you can have that foundation. Now, let's go with this. I need to find the inverse, which requires two things. It requires the determinant and it requires the adjoint. So the first thing I'm going to do is check out what's the adjoint, what's the determinant of P. So let's go. The determinant of P is equal to, remember we're using our diagonals, diagonal 1. Diagonal 2. In diagonal 1, we're finding the product of the elements on diagonal 1, and this gives me 4 times 2. Take away the product of the elements on diagonal 2, that gives me 3 times 1. That simplifies to the 8 minus 3. So the determinant of P is 5. What does that mean? Do you remember? What does it mean about the matrix? Does it have an inverse? Yes, it does. Because the determinant is not 0, it means that P is non-singular, and I can therefore proceed in finding its inverse. So we've found the determinant. Now we need to find the adjoint of P. The adjoint of P, remember that the adjoint is a matrix itself, representing matrix P, where we are looking at same diagonals. But we're going to do a rearrangement here. We're rearranging, switching the elements on diagonal 1, so now I have 2 there and 4 there, changing the signs of the elements on diagonal 2, so I have negative 3 there and negative 1 there. So now I have the 2 things that is required to actually find the inverse of the matrix. So we're going to put it all together. So let's go. I switched the elements on diagonal 1, switched the elements on diagonal 1, so this is 2 came to where 4 is, 4 came to where 2 is, change the position, the signs on diagonal 2, so this becomes negative 3, negative 1. Notice I did not switch the elements on diagonal 2. Where do we go from here? We're going to put it all together. Are you ready? Let's put this all together. We're going to put this all together. Now I'm going to go substitution. Substitution. I have the determinant, so the inverse of P is equal to 1 over the determinant, in this case it's 5, times the adjoint. Adjoint is 2, negative 3, negative 1, and 4. How do I proceed from here? I have a fraction multiplying the elements in the matrix. This number multiply all elements inside this matrix. Just as how you would have done if you had a number outside our bracket and you wanted to multiply it by the bracket, it means it must multiply everything inside. Since this is a fraction, I'm going to use these as fractions as well. So all whole numbers are placed over 1 to represent fractions. So I'm going to go ahead with my multiplication. 1/5 is multiplying 2, which means that the numerator multiplies the numerator, denominator with denominator, top with top, bottom with bottom. So that gives me my first element to be 2/5. Because 1 times 2 is 2, 5 times 1 is 5. That's my first element. I'm doing my inverse. Next element. 1 times negative 3, that's negative 3. 5 times 1, that's 5. So that's negative 3/5. Going down to the bottom. 1 times negative 1, that's 1, 5 times 1 is 1, so that's 1, negative 1/5. And the last element, 1 times 4, that's 4 over 5 times 1, that's 5. Always leave your elements in your matrix as fractions, either proper or improper. Do not convert them to decimals. Remember that decimals are often approximate values, while fractions are the exact numbers. So try to leave those fractions in your matrix and do not convert them to decimals. You will reduce them, however, if they can be reduced. In this case, the fractions couldn't be reduced, so I'm leaving them in the form as is. So what I've done is I've now found the inverse of my matrix, and I'm always going to be leaving with you one to do for yourself. Can you find the inverse of matrix M? If matrix M is negative 1, 4, 0, 3, can you find the inverse of matrix M? Go ahead, go forth and conquer. You can comment, share, like. Have a good day. There's matrix M. Matrix M is negative 1, 4, 0, 3. Can you find the inverse of matrix M?